So this question is going to be how to use bounds in calculations. So the question is, a rectangle measures 7 centimeters by 10 centimeters, where each has been measured to the nearest 1 centimeter. What is the upper bound, or UB, for its area? What is the lower bound, or LB, for its area? So the point of the question is we don't know the exact measurements of this rectangle. We know that the length is 7 centimeters to the nearest centimeter. That means in reality it could be anywhere between 6.5 and 7.5 centimeters. It can't actually be 7.5 exactly because that would round up to 8, not 7. But for the purpose of this question, this is fine, 6.5 to 7.5. And similarly, 10 centimeters to the nearest centimeter means it's somewhere between 9.5 and 10.5. So what is the upper bound for the area? Well, upper bound means the maximum possible. Well, since area is length times width, to make area the maximum area, we obviously want the maximum length multiplied by the maximum width, which is our max length is 7.5 multiplied by 10.5, the max width, and we get a maximum area, our upper bound for area, as 78.75 centimeters squared. For lower bound, we'll do the same thing, but now we want the minimum area, well, that's the minimum length multiplied by the minimum width, and that is 6.5 times 9.5, which is 61.75 centimeters squared. Great, so far so good. Now let's do a slightly trickier question where we're given the area to start off with, and we want to work back to find the width. So in our new example, now we're going to have a rectangle has length 80 centimeters to the nearest 10 centimeters, and area 1000 centimeters squared to the nearest 100 centimeters squared. Find UB for its width. In fact, well, let's make it slightly trickier. Let's find UB and LB for its width. Okay, we want to find the upper bound and the lower bound for its width. Okay, so let's go back to what our actual measurements mean. Well, 80 centimeters to the nearest 10 means 75 to 85. And 1000 centimeters squared to the nearest 100 centimeters squared, that means anywhere between 950 and 1050 centimeters squared. Now, we're asked to find its width. Well, because area equals length times width, that means width is equal to area divided by length. Now, to find the UB for width, that's the maximum width. Well, since width is area divided by length, to make that as big as possible, we want the thing on top, the numerator, to be as large as possible. So we want the maximum area, but we want to divide a big number, the maximum area, by the smallest possible area. We want to divide that by the minimum width. So this is a key point that people get wrong. Just because we want max width doesn't mean we want max area. Oh, sorry, I wrote width here, and that should say length. So just because people say, just because we want the max width, doesn't mean we want the maximum area, maximum length. We have to look at the formula. To make width as large as possible, because this is a division, we want the thing on top of the division to be as large as possible, and the thing we're dividing by to be as small as possible. So the maximum width is maximum area, which is 1050, divided by the minimum length, which was 75. 1050 divided by 75, that gives a maximum width of 14 centimeters. Similarly, if we're doing the lower bound, which is the min width, now we want to be dividing as small as possible area by as large a number as possible. So we want the minimum area, 950, divided by now 85, which is 11.2 centimeters to 3 significant figures. It doesn't go exactly. And there we go, the upper bound and lower bound for the width.